Hi, this is Estelle Trengove. This is part 2 of my videos on resistors in series and resistors in parallel. And in this video, we'll quickly look at the special case of the current divider, which is two resistors connected in parallel. And then I'll do a worked example of resistors in series and resistors in parallel. For resistors in parallel, we know that 1 upon R equivalent from the previous video is equal to 1 upon R1 plus 1 upon R2, and that is equal to R1 plus R2 divided by R1, R2. So in other words, R equivalent of two resistors in parallel is equal to the product of the two resistors, R1, R2, divided by the sum of the two resistors, R1 plus R2. And this is also a result that is used quite often, two resistors in parallel, so it's worth remembering this as a shortcut. We also know that by Ohm's law, in this little circuit, Vs is equal to I times R equivalent. Therefore, Vs is equal to I R1 R2 divided by R1 plus R2. And let's call this equation 1. Also, by Ohm's law, we know that I1 is equal to Vs over R1. Since the resistors are in parallel, the voltage across all of them is Vs. And we know that I2 is equal to Vs over R2, and we'll call this equation 2. Then we're going to put equation 1 into equation 2. And that gives us I1 is equal to I R1 R2 over R1 plus R2 times 1 upon R1. And so therefore I1 is equal to I R2 over R1 plus R2, and similarly I2 is equal to I R1 divided by R1 plus R2. And so in this case, you can see that the I is the same in both equations, and R1 plus R2 is the same in both equations. So therefore, we can see that for a current divider with two resistors in parallel, I1 is proportional to the resistance of the other resistor, R2, and I2 is proportional to R1. And now we'll take a look at the worked example. And the first thing that we can see is, remember that two resistors that share a node that they and only they share are in series with each other. So this 6 ohm resistor shares a node with the 10 ohm resistor and only with that 10 ohm resistor. So these two resistors are in series with each other, and so the resistances can just simply be added up. And then resistors that share two common nodes are in parallel with each other, so we can see that this is one expanded node and this is one expanded node. So in this case we've got the 20 ohm resistor in parallel with the 40 ohm resistor. So we can simplify this circuit so that it looks like that. We still have the 9-volt battery, and we've got connected to it a 4 ohm resistor, and the question asks, find the current I, and the current I is here on the drawing. So we still have the current I flowing there, and in this case we've got the 6 ohm resistor, and then 20 ohms in parallel with 40 ohms gives us 13.33 ohms. So this is a 13.33 ohm resistor. And then we still have the 7 ohm resistor and the 10 ohm. And we're combining the 6 ohm and the 10 ohm in series with each other. So that gives us 16 ohms over here. Looking at this drawing now, we can see that over here, the 6 ohm and the 13.33 ohms are in series. So we can just combine them, and the 10 ohm and the 16 ohm share this expanded node and this expanded node, so they are in parallel with each other. So we've got 10 ohms in parallel with 16 ohms. And so we can redraw our drawing again, and this time we've still got the 9-volt battery, and we've still got the current I flowing through the 4 ohm resistor. We've combined those two, so we've got 19.33 ohms. We've got the 7 ohm resistor, and then 10 ohms in parallel with 16 ohms gives us 6.15 ohms. That's the 10 in parallel with 16. And now you can see that we can simplify it even further, because remember, our ultimate goal is to find I. So now we can see these two share this node, and they don't share it with any other element, so these two elements are in series now. And so we can redraw the circuit once again like this. We've got the 9-volt battery. We've got the current I flowing, the 4-ohm resistor, the 19.33 ohm resistor, and that is the 7 ohm plus the 6.15 ohm, so that's 13.15 ohms. And now we can see that these two are in parallel with each other. So 19.33 in parallel with 13.15 gives us 7.83 ohms. And this circuit can therefore be reduced to the 9-volt battery with the current I flowing and the 4 ohms and the 7.83 ohms. And now you can see that these two are in series because they share that node and they don't share it with any other element. So finally, our circuit can be reduced to this, a 9-volt battery with the current I and 4 ohms plus 7.83 ohms, which gives us 11.83 ohms. And now we can finally work out the current I, which is equal to 9 volts divided by 11.83 ohms, and that is equal to 0.76 amps. That's the end of this recording.